We look forward to connecting people to him. So yes, before we continue, next on our program is we're going to allow each of the companies here today to present themselves, just to give you a little bit more of an overview of what they do and how they bring innovation to the field of solar energy. So I ask each and every one of you, if you have any questions, please feel encouraged to post them in the chat as we continue. There will be a panel discussion following the presentations, and then we'll also ask the questions that you've posted in the Q&A session. So I think our first company is SolarEdge. SolarEdge is the number one company in the world for inverters, and they really invented a fantastic inverter. So I can't wait for Warren to share more on that. Warren, over to you.
Yeah, thanks so much, Steph, and welcome to everyone here. Good afternoon, good evening, wherever you are. So yeah, I'm part of SolarEdge in South Africa. We've been in South Africa for probably 6 years now. We fly under the radar a little bit, but we've been very active in the commercial and residential rooftop space, and we're starting now to get more into the utility scale market. So I'm just going to give you a brief overview of the company, and then I'll show you a short video just to give you an understanding of how our technology is different to your standard sort of string configuration, which is probably 90% of the market at the moment. So just to give you some facts on SolarEdge, we were started in 2006 to revolutionize the solar industry by inventing a better way to harvest and manage energy in PV systems. And today, as Steph mentioned, we are a global leader in the smart energy technology. And by developing world-class engineering capabilities and with a relentless focus on innovation, we create award-winning products and solutions that power home, businesses, and transportations while driving future progress. Our vision is to believe that continuous improvement in the ways we produce and manage the energy we consume will lead to a better future for us all. And just to give you an understanding of our global reach, we've installed systems in over 133 countries across 5 continents. And we have presence in 34 countries at the moment. And on our books, we have over 47,000 installers that use our equipment. And basically, our systems are a start to finish solution. We assist with design, implementation, commissioning, and of course, monitoring and warranty right through the full values chain of the products. And then, of course, we help manage the asset for the end user as well. So just to give you an idea of our numbers, as we're an optimized solution, we have inverters as well as optimizers, and the optimizers are basically the MPPT or maximum power point tracking that sits on the back of the modules. And we're the number one inverter manufacturer in terms of sales. We've shipped over 4.5 million inverters worldwide and over 90 million optimizers. And as I mentioned earlier, we in 34 countries in present day. So how the SolarEdge commercial systems work, we go through the whole topography. So you'll see on this slide, we do rooftop PV with the optimizers. You can do carport PV with obviously in more advanced markets with EV chargers as well. Then you'll see we also do ground mounts and big commercial size systems. Our systems, once integrated, have full energy management and data monitoring and alerts management on the site. So everything is handled by SolarEdge. So it's one route to market, one point of contact for any issues. And of course, monitoring and looking after the asset for the end user is all done under one portfolio, which makes it a lot easier, I think, for the end user, as well as the installers that install our equipment as well. And how that works is basically we start from implementation. So we have a free online portal where you can design your solution, whether it be rooftop or ground mount or residential, for example. You'd be able to design a solution using the address where the location will be. On that designer, you'd be able to ensure that the design is not only validated using the components that you're using, but you'll get a comparative PV simulation based on any other inverter that you'd be looking at installing, or perhaps the end user would like to have a comparison on, and you get a full OCRE analysis and ROI, and that's all done on as I mentioned, the dates for the designer, you know that the complete design and everything is done correctly. We also offer online training on our portal, as our equipment is not the same as standard string inverters. We offer the training to be able to install it, monitor it, and of course do on-site support, etc. With the remote monitoring, this allows basically module level monitoring issues on even the modules repeatedly, and we have either online solutions to be able to fix the system, or then obviously there'd be an opportunity for the installer to go to site. So you get that opportunity to find out exactly when the system's not performing for whatever reason, and that gives you sort of clear indications and control of the system as well. And that's both for the installer that's handling the OEM contracts or the end user as well. And you'll see on the bottom thing, basically on operation and maintenance, with our designer and monitoring system, you basically, with the module level optimization, you basically get real-time information from each individual module that's in this particular solution, how it's performing, if there's any issues. We also have PID resistance as well. And all of that can be monitored remotely. And a lot of the troubleshooting can also be resolved without having to purposely go to sites. And I think that works well for certain countries within Africa where certain locations are quite remote and it's quite a distance to get to sites. And that's obviously gives us a much better value compared to some of the other manufacturers out there. So I'll just give you, I'll put on a video and just to give you a bit of understanding. As SolarEdge is an optimized solution, it does start a little bit non-technical, but I think it gives a good understanding of exactly how our solutions work. And I'll show you the quick video and just let me know if everyone can hear once it starts.
A photovoltaic system is made up of panels which produce DC power.
It's all good, Warren. If you can just increase the volume a bit.
There we go.
Power into AC power that is fed into the
There is no sound to the video.
downtime. For these reasons, decentralized architecture that uses multiple string inverters instead of central inverters is gaining market share. String inverter topology allows higher system availability, lower land use, and lower operation and maintenance expenses. While central inverters are typically used in ground mount installations, string inverters are used in both. Still used in the majority of large-scale installations, it suffers from a number of significant drawbacks. First, the system power output is limited. In traditional systems, panels are wired in a series as a string. Each panel has its own power production profile. This is a function of its manufacturing variables, installation parameters, and shading patterns. This means that panels don't usually work at their maximum power point. Second, the traditional system has design limitations. Strings are shorter, and all strings connected to the same inverter need to be at the same length, use the same title, same angle. Real-life installation constraints, especially in rooftop systems, result either in wasted roof space or unnecessary duplication of balance of system components. A third drawback is safety issues. The DC cables that connect the panels to a string carry high voltage as long as the sun is shining. The traditional inverter cannot shut down the DC voltage of the panels, and therefore there are serious associated risks for installers and firefighters. And lastly, a traditional system cannot track power output, temperature, or any other parameter of a single panel. This makes it impossible to identify specific panel level problems remotely. When we started to develop the SolarEdge solution, we looked at the challenges posed by traditional systems and defined 3 goals: to optimize and monitor power generation of each panel, to use the same installation methods and components used to install traditional inverter systems, and to minimize long-term operation and maintenance costs. So, we built a topology that meets all optimized inverter topology. Our solution splits the traditional inverter functionality into the power optimizers are located on the panels, turning them into intelligent panels. These power optimizers maximize system output by providing panel-level tracking and real-time adjustments of current and voltage to the optimum working point of each panel. The simplified inverter is installed similarly to a traditional string inverter, but it is only responsible for DC to AC inversion and grid connection. In comparison to the limited design of string inverters, designers of SolarEdge commercial systems enjoy great flexibility and are able to fit more panels in a given space. Additionally, the SolarEdge solution enables connection of much longer strings. This significantly lowers the number of strings per system and reduces balance of system costs. Our solution includes two additional features: a panel-level cloud-based monitoring platform, which is accessible from any computer or handheld device, and an enhanced safety mechanism. The SolarEdge monitoring platform provides full data and reports at the panel, string, inverter, and system level. This allows for immediate fault detection, real-time alerts, comprehensive analysis, and remote troubleshooting. These important features reduce long-term operation and maintenance costs and increase system availability. To provide enhanced safety, we have incorporated panel-level safety mechanisms to protect installers, electricians, maintenance personnel, and firefighters. With the SolarEdge solution, whenever AC power is off, the high DC voltage of the string is reduced to a safe voltage. This solution meets new safety regulations in the major PV markets in which we operate around the world. To summarize, thanks to panel-level optimization of power harvesting, investors and system owners can expect higher revenues throughout the system's lifetime and future-proof against unexpected variables that could lead to underperformance. Long-term operation and maintenance can be managed from remote, minimizing the requirement for site visits and time spent on-site. Bottom line, with higher revenue and lower OPEX, the SolarEdge solution provides superior lifetime value for EPCs, O&M providers, and system owners.
Great, thank you so much, Warren. I think if you could just post the link to that video in the chat as well, and then we'll disseminate it afterwards.
Perfect, I'll do that.
Great, Warren, thank you so much. It's always a pleasure working with SolarEdge.
Absolute pleasure. Thank you so much.
Great stuff. I think you also mentioned there about if there's a covering of the solar panels or anything that might obscure the efficiency of the panels itself, of the PVs. And I think on that topic, there's no one else that can give us a better answer than Michelle from Ecopia, explaining what they do.
Thank you. Just let me know that you can see my screen.
Okay, thank you.
Okay. So hi, everyone. My name is Michelle Harrell, and I'm the marketing director at Ecopia. Ecopia is the world's leader in robotic cleaning solutions for utility scale, for large-scale solar PV for nearly a decade. I'm very happy to be here with you and to introduce you to the story of Ecopia, and thank you very much for taking the time and joining today. Ecopia started operating back in 2013, and today has more than 15,000 megawatts of secured agreements in over 30 worldwide projects in 4 continents. And today we're spread with a local presence in about 4 continents with offices and R&D centers. And today we have been working with the major IPPs in the market, with companies like Total Energies, Azure Power, Shell Energy, and many other companies that you see here in the slide. And we put our focus and efforts on creating long-term partnerships with our customers and business partners, starting from the beginning of the solar site process, from the model maker through the tracker provider, making sure that we have the financial stability, as well as working together with the EPC. And I think that when looking at a large-scale solar site today, it's almost impossible not to work together, and all of the players in the segment must operate in order to succeed in the mutual goal of maximizing energy production. And it's a joint effort of all of the players in the market. In the past decade, Ecopia signed about 16,000 megawatts of projects, while we focus on specific regions. And hopefully this is another step into, I want to say, introducing Ecopia to the local market in South Africa. And I hope this is the beginning of a long-term relationship also locally in South Africa. We have projects and offices globally. So starting from the US, projects in California, Mexico, and offices in Chile, all the way through Spain and the Middle East, India. We've been expanding in the past few years and working with more and more players in the market, expanding our projects and the operations globally. Ecopia has developed over the years a complete suite of solutions that answers a few market needs and complexities. We've entered the market with the E4 product that was meant mostly for traveling on rails. And since then, and due to the complexities and the tracker providers' implementation into the market, we've launched the T4 a few years ago, which is a lightweight robot traveling on trackers solar sites. And recently we've launched the H4 that fits perfectly for both fixed tilt and single axis trackers. And of course, together with our robots, we provide a cloud-based monitoring solution that offers online dashboards and analytics on the solar site operation and maintenance to ensure that our customers have the full visibility and control to see what's going on their site and see the robot's operation and the status on a daily, weekly, monthly basis, and to analyze the productivity of the solar site. And when designing our products at Ecopia, we have a few factors that we keep at the top of our priorities. First one is that safety comes first, and we have a do no harm approach in terms of making sure our robots are in the lightest weight possible and using gentle microfibers to make sure the safety of the solar panels. We work closely with the PI Berlin to ensure that we have the right certifications, and also to ensure that the effectiveness of the cleaning is currently towards the 99% of effectiveness. And the cleaning coverage is also important when talking about effectiveness. We can reach up to 1 kilometer in less than 1 hour, which is highly impressive. It allows us to maximize the site's productivity, to prevent the robots from working in crucial times and to make sure that they're not creating any shadows on the solar panel. So it's important that we make sure our solutions are as effective as possible. The robots are completely water-free, so we're using microfibers, as I mentioned before, and they're fully autonomous, which is important. It means that there are no personnel needed on site. And thanks to a solar panel that is connected to the robots, the robot is self-powered, so it's self-charging, and it's using a battery that is connected to it. So there's really no human intervention, and the robot is completely autonomous, working in a remote area. And going back to working with the close partners, as I said, with such a wide range of innovations and technologies that we hear about some of them here today in this webinar, I think that one of the most important factors is the power of compatibility. And it's true for all of us in any side or segment of the solar story. And I think the focus of having a agile hardware that allows us to be compatible to any module structure, any type of tracker is a crucial part in our segment. And while compatibility is key, Ecopia is also putting testing at its core. We have a 3,000 square meters R&D center with the simulators and the severe testing. Our robots are meant to work in the field, and they need to survive the field conditions. You can only hear the news about sandstorms and the extreme weather conditions that we're facing in the last few years, and it's only becoming more and more extreme. And our goal is to verify that the robots can work for about 25 years in those harsh conditions. And this is why testing is one of the key elements of Ecopia. Besides the severe testing, we also work with some of the best softwares in the market. We collect thousands of data and analytics points every single day from various fields around the world. Through those softwares, we collect all of the data into one client's data hub, where we offer our clients a complete visibility of the site performance. And we ensure that the customer and our client is always updated with the current status. And it's from the malfunctions through the battery life, through weather conditions that they need to be aware of. Everything is visible through user-friendly dashboards. And most important, it's allowing them to analyze the data, to perform, for us also to perform predictive maintenance and preventive maintenance, and to take care of malfunctions even before they happen. And to, at the end of the day, to make sure that the site is maximizing its energy production. And just before we say goodbye, I would like to show you an actual example of a typical 500 megawatt site that is planned to operate for about 25 years. Instead of spending 3 liters of water per panel and 3 cents of a dollar per kilowatt for cleaning, Ecopia's dry clean solution that actually helps save 2.23 billion liters of water. It helps increase the site's energy production by 6,000 megawatts per hour. And the most important, how does it impact the site's revenue? It's by saving $19 million on cleaning costs and increasing the energy revenue by $21 million. And it's making a total value of nearly $40 million for the site's owner. So this is just an example. And with that, I would like to thank you again for joining this event. I truly believe that we're fortunate to live in an era and experience such innovative and technologies that are really changing the industry and our lives. We are committed at Ecopia to ensure that we're creating long-term partnerships with our customers, and we continue to develop superb solutions and innovations. And I invite you to continue the discussion on LinkedIn. And once again, thank you very much for joining this session.
Michelle, thank you so much. It's always fantastic to me how these technologies tend to pay for themselves in what you say. In this case, it's water. And if you think about the arid desert of Namibia, and it has some of the best radiation out there, but yeah, you don't need water. And also your technology is completely developed that it can sustain those harsh environments with wind, sand, storm, regardless of the climate. I mean, even if you go up to the rainy storms of Cameroon, it's still applicable, which is absolutely fantastic. No, thank you so much. What I like about innovation is it's not always mind-blowing innovation. It's sometimes just thinking logic about stuff. And that's exactly where Hilton comes in from Elspec. Ever since I met Hilton, it's always about bringing it back to basics. And I think, Hilton, I'm very grateful that you're here today, and I'm looking forward to what you're sharing with us.
Hi, good afternoon all. Yeah, great to be part of this session. Some global players here, which is absolutely incredible. We've personally been involved in the South African market in power quality for the last 20 years. Since about 2007, we've been integrating Elspec equipment into the Southern Africa and into Africa, and with incredible results. But the entire focus is on power quality, and as Steph quite said, it's about let's get back to basics. And one of the things I say to our clients is that we've so over-engineered our environments that we forgot about the fundamentals. And once we take care of the fundamentals, we can then start looking at everything else. One of my colleagues is on the line with us. He's the global metering technology head for Elspec, Asaf Leifer. So if there are any questions later with regards to this, we can definitely answer them. But yeah, if we get into, I'll just bring up the presentation. If we bring this up, if we look at the integration of equipment into the network, whether it be from a load side, whether it be from the network side, we sit in that space where we see an incredible increase in electronic equipment from the load side. And this has had vast implications on both the network, on equipment on the network, et cetera, and specifically South Africa and Southern Africa. We've seen a degradation of the network and the supply authority component into this network. So we're really seeing these two, we're trying to get more sensitive equipment onto the network, but on the other hand, we're sitting with a more volatile network. How do we get these two to marry up in a much better manner? And the Elspec answer to this is measurement. It's measurement from start to finish. It's not just a quick study for a couple of hours beforehand and put equipment in and then afterwards. The networks change on a daily basis. Your neighbors are going to change. Your point of connection is going to change. So if we go into just this presentation, there was a study done by Leonardo Energy and Power Quality in Europe across the European grid. This was done in 2006, 2007, well documented. But the losses back then on the network due to power quality, that was interruptions, equipment failure, etc., amounted to 150 billion euros. And this was 14, 15 years ago. So when we look at it, essentially, the more we know about this raw material called electricity, and the more we respect it, we find traditionally, when it comes to metering, a lot of companies don't put the emphasis like they should do on the metering part of it. And hence we look at average data, et cetera, and when things start failing, which I'm going to show you a couple of examples shortly, but when things start failing, you don't know why, and you don't know how. And when being forewarned is forearmed. So being able to look at these networks from a different perspective by having the right data. So obviously looking at the photovoltaic sector, whether you've got small farms or large farms, we always look at the point of common coupling onto the network. And it's important to do the pre-study and the post-study, because the amount of electrical parameters that we're now able to visualize and understand in a continuous high resolution manner gives us the ability of understanding a lot more about what's going on to that network. And when you connect onto that network with PV systems, whether it's a small farm or large farm, whether it's a grid type connection, etc., you need to know the implications, because you're plugging in an asset onto this piece of the network, and essentially you know nothing about that point in the network traditionally, and what the implications are on the risk on your asset that you're going to be putting into that. So the more we know about that, about this raw material called electricity at that point, the better you can understand and mitigate the risks on your assets that you're connecting into this. From experience, global experience that Elspec has, they've started seeing that the relationship between the energy producers and the consumers, and these various different sources of power are changing our networks drastically. We've got a lot more distributed generation systems than we ever had before. And this is going to change our energy going forward. What is that going to, how it's going to change it? I don't know. But over the next 5 years, we are certainly going to see a variety of different challenges. If I look at this, the traditional way of doing metering has always been to do tell the meter what you want to store. And from that, you do an average recording. And yes, great, it's a good recording to have. However, if you look at these two recordings on the right-hand side, the yellow profile shows the average of this data trend. Both the voltage on the top and the current on the bottom. However, when you take a cycle-by-cycle recording, you're sitting at almost 1.7 kA on this installation, and the voltage is dropping down to below the 370 mark. So it's imperative to understand the network in a cycle-by-cycle manner. And traditionally, you have to tell the instrument what you want to see on the network. We're not clever enough to know what's going on every point in the network. Then the instruments need to be able to tell us this. So what the Elspec black box range actually does for us, it stores the sine wave in a high resolution, 256, 512, 1024 samples per cycle. We store the voltage and current for the full period of time. I've got clients that we've had on our cloud server for 3 or 4 years. I can go back 3 or 4 years and show you every single network waveform from a voltage and a current perspective because of the Elspec technology. So it's the whole black box approach. We might not need it today, but when the pawpaw hits the fan, we have the data and we are able to analyze it and understand what's going on. In this instance here, just one of those, when you look at the network, this particular voltage profile is a step change on there was a tap change on the network, but this is over 1850 cycles. If you were to take an average of that, you would never see the step change in this network because the average would not see it as an event. So therefore, on average, you're going to just see a slight change in the voltage profile without understanding that it's actually a tap changer that has brought this about. We've got a whole lot of these meters in the city power network, and there's probably about 600 of them that were over the last I think it was about 5 or 6 years that they started deploying these into the network. And when we put them in on the 275 kV network, we could see that the tap changes had a transient condition that was bringing into the network. So anything that hooked up onto that same network was seeing that transient. They were able to look at the tap changes, do maintenance proactively instead of reactively, solve the problem from a risk perspective. So it all comes down to risk. So from a power quality perspective, we're looking at managing risk on behalf of either the supplier, the customer, the network operator, etc. And when you can drill right down into the change in state where the tap changer actually changes, look at how the granular data that you're able to then visualize. And yeah, this might not be a problem and bring a problem directly, but at least you know that something's happening on the network and you're able to start understanding it. This example illustrates the power generated at a voltage level of with 50 kilowatts connected to an LV network, fluctuations in the power shown. So when you look at an average profile, you're not going to see what the network voltage implication has on your equipment and on the production. So it's just showing you examples of how we have been measuring up until now and going forward, what the better resolution data is going to show us a much different picture. When we zoomed into this particular part of the network, 9 seconds window shows the following figure. The shape of the voltage, power raised, is caused by malfunctioning of the photovoltaic system, causing unnecessary voltage changes. So we can drill right down into network events. We can go from many days right down to cycles and start understanding and evaluating. this is a lovely case study where we've recently done a recording on a plant. They were losing equipment, they were losing chillers, and it was from a mechanical perspective that they were losing chillers. And we said, let's hook the equipment up. And you can see here that the large voltage drop is where the changeover is from Eskom to the generator. But then when the generator moves back and you change back from the generator to utility, you can see a large voltage drop there, which should not be happening. Either you should see a definite switch off and a switch on, or you should see a smooth transition if it's a synchronized set back into the network. What we found when we opened up, so we've gone from 14 days to literally cycles on the right-hand side here. The equipment, the changeover was happening far too quickly from the generator back to the network. If you look at the blue phase voltage, so the current drops off on the bottom, you can see that, but the blue phase voltage on the changeover changes to the green. So look at that. Then the green changes to the blue. Look at that transition over there. So now you can imagine the mechanical interaction required, and hence we have almost a 2.5 kA peak on the current waveform as this network tries to integrate and synchronize with the new phase group when connected to the utility. So this is where high resolution data benefits you from the start. Another one that we've had, and is a very well documented case where one of the engineers in Eskom, Willem van Schalkwyk, logged and put one of the Elspec instruments in on a high voltage network on a large farm. And the background to his to the investigation was the standard NRS 048 power quality instrumentation that he had in the network was not showing him what the problem was. It was not giving him the ability to identify the source of the issue. He had standard NRS 048 type loggers in, but what they started looking at was there was a range of superharmonics, okay, which are outside of the standard 0 to 50 on the harmonic range that the NRS 048 requires us to measure. So we are seeing that there's a higher harmonic range developing on the network in certain instances. It's not all over the place, but we need to be able to understand this, and we need to be able to understand what the implication is. Do we need to do something about it? And if so, how do we design and develop around this new market?
Hilton, I hate to interrupt you there, but we're running a bit short on time. If you can just quickly summarize. Sorry, man.
Sure, not a problem. So essentially, from a power quality perspective, the Elspec solution gives that ability of not just understanding your average data. It literally stores a sine wave and gives you that pre and post ability of designing around, reducing the risk, and understanding and mitigating problems in a much better manner. So thank you.
No, fantastic. I think when we look at our current, at the grid in general, and we see the anomalies in the power quality and how it ranges, then we kind of understand why after load shedding we frequently lost transmissions and burn substations and so on. It completely makes sense. No, thank you so much, Hilton, for that very insightful presentation. I think up next we have Peter. Oh my word, Peter Greiner. Almost forgot your surname, but Peter has developed a fantastic technology where you combine solar technology to generate both electricity and thermal heat. So Peter, over to you. And I would just like to remind everyone, please post your questions in the Q&A box and we'll get to it. Thank you so much.
Good afternoon. My name is Peter Greiner. I am the inventor and one of the patent technologies which produce electricity and hot water on the same system. And I will present you a short video, and you can see what we are talking about.
Peter, we can't hear the.
Has
Oh,
developed
there we go.
innovative
Fantastic.
ultra triple boosted hybrid thermal PVP solar technology. This patented technology significantly improves energy generation efficiency and produces greater quantities of hot water within the same physical platform. Using the latest and most advanced bifacial photovoltaic panels, electricity is generated from both sides of the panel. On the front end through direct radiant sunlight, and on the back end from the reflection of sun rays, known as the albedo effect. Water is introduced into the panel, which is encapsulated by a layer of thin tempered glass. This water is circulated via a pump linked to a heat exchanger. The circulating water within the panel surface area has the ability to limit the temperature buildup on the surface of the panel, which in turn prevents the development of hot spots on the panel. This temperature uniformity across the entire surface area of the panel increases the efficiency of the PVP by at least 30%. Panels can be installed on either a fixed stationary mount or on our patented 4-axis differential telescopic elliptical arced multiple sun tracker system. This leads to 80% more power generation than comparable fixed mount systems. Warm water exiting the PV panels is streamed into the heat exchanger, which then sends hot water into a hot water boiler for distribution of all sanitary hot water needs, such as in the shower, bath, sink, dishwasher, or washer. The surface hot water produced can also be integrated with a DC hybrid air conditioning unit, which improves cooling efficiency of the AC unit, as well as reducing electrical consumption by an additional 40%. The combination of the albedo effect, solar trackers, and cooling system, along with hot water reservoir, allows the PG solar hybrid electric and thermal system as much as 200% more energy production than that currently seen and realized from standard fixed mount systems placed on a similar physical platform. The PG solar hybrid thermal technology can be integrated into any roof structure as a roof tile, where it will provide enhanced electricity production, greater thermal hot water production, enhanced thermal insulation of building structure, reduced heating and air conditioning costs. PG Solar, helping you save money while saving the world.
Okay, as you can see, I present the concept, and now I will go to our video, to the presentation of the system. Okay, as you saw before, we are talking of bifacial photovoltaic panel that produce electricity, hot water, increase the efficiency, and Now we modify the system by change the concept. We integrate the system with additional panels, with additional hot water boilers. And also, as you can see here, we integrate it with the hybrid air condition, with the system of the storage, which take the hot water and the electricity, and instead of 100 kilowatt that you charge the system, we take the electricity and put it in our storage with our revolutionary of hybrid turbine engine that multiply the electricity output, and instead of lithium battery, we use the storage in compressed air and integrate with hot water. It can be residential, it can be commercial, and as we spoke, we double almost 180% relative to what is existing in the world. Also, we use the, as I say, compressed air, put it in our engine, and also integrate hydrogen that can multiply the power output relative to any engine in the world. Thank you.
Great, thank you so much, Peter. That was a very insightful presentation from you. On the topic of thermal energy, I think, Ben, you have also a very interesting technology that incorporates thermal and visual imaging, if I'm not, well, to track the efficiency of a PV. So yeah, over to you.
Thank you very much, Steph. Hi, everyone. Good evening, morning, afternoon, wherever you're looking from. I'm Ben Grodsky, co-founder and CEO at Soltrex. And basically our goal is to help enable the fast growth of solar energy throughout the world. So just making sure, can you see my presentation? Not yet?
No, not yet.
All right, here we go.
There we go, yeah.
All right. Yeah, and so we do so by with using automation technologies. So I'm gonna skip this. We all know that the world is moving, transitioning to solar energy. And this is a photo I want to look at. So we are a team of automation or robotics engineers. And when we were looking at this picture of a solar plant that is built out of millions of panels and that are aligned in perfect identical rows throughout and extended on huge areas, sometimes larger than entire cities. This one in India is larger than the entire city of Tel Aviv. So these energy plants are remoted areas, mainly, and are remoted also from people, that require ongoing maintenance in order to keep the peak performances of a solar plant. When we're looking at this picture, we understand that this is the perfect use case for automation. Now, in recent years, the cost for building solar plants have been dropping tremendously. And this is thanks to technology that is increasing the photovoltaic efficiency, inverters, any kind of reduction in capital expenditure. However, operational expenditures remain relatively high, and because they mainly rely on manual labor, which is complex to operate and basically very expensive. Now, when we're talking solar energy plants and they make the perfect use case for automation, it only makes sense that these plants that needs to work in peak performances and to be stable, they should work automatically. So this is the team we're all, so I should have said, we're an early stage startup. So we're developing the technology now, and we will be ready. We will be piloting in a few months. So I will show you now a short video of our development, and then I'll go back to the presentation. Okay. So our solution is based on unmanned ground vehicle that basically surveys the site, travels along and across the solar plant, and is able to conduct the various tasks needed in the solar plant. One robot is able to service up to 100 megawatt of a solar plant, and reducing up to 80% of operation maintenance on the solar plant. Equipped with a robotic manipulator, cameras, and sensors such as thermographic imaging and visual imaging, we're able to actually turn the entire operation of a solar plant to digital. Now, the cool thing about it is that we didn't have to invent anything of the hardware. Coming from military knowledge, intelligence, and from manufacturing know-hows, we're basically able to harness existing technologies like ground rovers, manipulators, robotic sensors, and we develop the autonomy that is needed in order to tackle the challenges that in order to maintain solar plants. So what about two main factors that are changing the way solar plants look in the future and currently? So solar plants are moving towards shorter panel rows, and that is thanks to the fact that we're trying to cause less impact to the ground. So instead of flattening an entire ground, which is also very expensive, we're today building solar plants and panels on the existing terrain, leaving it relatively natural. And thanks to the solar tracking technologies, we're able to do so with shorter rows on the existing terrains. The problem, however, is that now we are left with a big solar plant with a lot of separate short rows, meaning that in order to clean the panels automatically and in order to maintain the farm, some solutions are needed. And that is why we're basing our solution on an unmanned ground vehicle that is an all-terrain rover, which is able to interact with the panels on any kind of terrain. So basically having the system, we're looking at it as a multi-function platform. So gonna jump back to presentation. And so, yeah, so we're working on developing that. And basically, one of the cool things about it is the fact that such a machine requires zero installation, meaning it's a plug and play solution. And we don't need to involve the engineering team of the solar plant. We also don't need to force them to contract for long terms of periods for 30 years. So we're able to generate the flexibility that is needed. Because one of the problems in solar energy is the fact that maintaining the solar plant is pretty expensive, but you can't control your expenses because everything you want to do on site, meaning you have to bring a crew of people into the plant, which, you know, commuting over there with gasoline cars, getting there, everything has to be maintained and complex to operate. And the fact that we're able to simplify things and what I'm looking for is to enable operational flexibility. That is a great thing about being able to service solar plants in different kind of climatal conditions. So there's solar plants that have some rain in them, and there's solar plants that are suffering from a lot of dust. There's solar plants that have some vegetation that is growing and has to be maintained. So by having a ground vehicle that is flexible and mobile, we're actually able to reduce tremendously the maintenance of a solar plant. And yeah. Sorry. Okay, I'm going to continue. So we are design partnering and developing what we're doing together with some of the international largest, you can see here, Enel, EDF, and Light. And I'm going to show you a quick video of where we are right now and be open to questions. Yeah, so if you can see the video right now, you can see our system in moving alongside the panels and basically is able to interact with the panel seamlessly while moving on uneven terrain. And this is exactly what is needed in order to develop a multifunction platform for solar plants. So it's cleaning, vegetation control, inspection of the panels, inspection of the entire systems of the perimeter of the site. And in the future, we're looking to further automate the various tasks needed. Thank you.
Yeah, thank you so much, Ben. I think I'm going to ask all our panelists to switch on their cameras and their mics when they speak, and then we'll just run through a couple of questions. Thank you all for very insightful presentations. Ben, I think I'm going to start it off with you. It's a very interesting technology that you have, and you also notice that we're moving towards more solar plants where the panels are not necessarily aligned anymore in very long aisles. Now, in terms of concentrated solar panels, where instead of using PVs, they use mirrors to reflect heat upon one central unit where they capture the thermal heat, and then, you know, transform it into whether it should be heat, electricity, or so on. Does your technology also enhance the efficiency of the mirrors as opposed to the PVs?
Thank you for the question. So in theory, we are able to tackle this challenge as well. Either the concentrated thermal, as you described, or the mirrors that are reflecting the sun towards. Now, we are yet focusing on the photovoltaic because it's a much larger and faster growing market that we should focus on. But once we're in the market, we will be able to also target that as well. Yeah, thanks.
No, fantastic. Sorry, it was just a question that came up. It wasn't something I wrote down or anything like that. Warren, on to you. Someone in the question box already asked about how can that, or whether your inverter, or rather your, I forgot the word. Anyway, the inverter, the optimizer. There we go. Thank you. It's been a very long day. Anyway, whether your optimizer can be retrofitted to any PV, and in your answer, you did say that it's specifically designed for your PVs that you install, but also you are completely vertically integrated. You have PVs, you have your inverters, all the way through to lithium-ion batteries. How good is SolarEdge at retrofitting their solution to the existing solar plants that is already installed?
So yeah, thanks, Steph. Yeah, obviously our solution needs to work with itself. I know there's some other optimizers on the market that do work with various other inverters. As ours is a non-string inverter, you need to use the SolarEdge components. And yes, we are vertically integrated. We purchased a Korean Korean lithium-ion manufacturer a few years ago, and we've basically secured our own cells now. And we've actually just launched our first residential battery storage solution, which integrates with our residential solutions with optimization, etc. And we're hoping now in the new year, probably in Q2 next year, we will have our first commercial grade storage solution that will be available into the market as well. So we are working towards that. But yeah, our components all need to work together as we're vertically integrated. All the components need to be obviously a SolarEdge solution to be able to work together with each other.
No, which also makes sense. I mean, to get the highest efficiency, it makes sense to put together the same pieces of the same puzzle. And it goes without
correct.
saying.
And obviously, then there's, then if there's any issues down the line or warranties, it's one vendor that you go back to as opposed to multiple on sites when you have to integrate different technologies as well.
No, definitely, it goes without saying. Warren, on that topic of more residential batteries that's getting installed within residential markets, you also mentioned that you are bringing to market new EV chargers. So would this allow for residents to charge EVs from their houses?
Correct, yeah. So on the new residential solution, you can add an EV charger to the inverter. And how that's managed is because our inverters can be oversized on a residential solution by up to 200%. you can effectively have the battery using one portion of the inverter and then running the loads on the second half of the inverter. And what that does is then you can basically plan on the platform exactly when you're wanting to utilize that power to charge the EV. If it's plugged in during the day, of course, it will use directly from the sun. You can also then have it set up to either drain the battery storage that you have on site, or then run from the power that you've generated during the day and stored as well. So it really depends on the setup, but yeah, it will be integrated, and then it's all basically set up on the monitoring platform, how that power is managed and where it's put through it and at which times as well.
Interesting. Now, I know my other panelists are irritated with me just poking at Warren, but
No
you
problem.
also said you have the software where you can track. Will this software also allow you to sell back to the grid?
Yeah, so obviously there's an opportunities that if you're allowed to push back into the grid, we do have meters that connect up to the inverters, and that then can be monitored for pushback into the grid for net metering. And then we have a metering device that can then obviously limit to obviously meter the pushback as well as a draw from the grid. So that's also integrated as well. Again, there's obviously only certain places in South Africa that's obviously able to do so at the moment, but in the future we're hoping to open that up to other parts that are not able to do so at the moment. But yeah, it is possible, of course.
No, fantastic, Warren. Thank you so much.
No problem.
Hilton, on to you. I hope the signal is good up there in space, but it's the second joke I made about your background. I'm sorry. So my question is, I touched on this with Warren, but in terms of retrofitting, we know that we have a large infrastructure in South Africa. We have a very large, let me just switch this off. We have a very large grid as well. So how can we integrate the Elspec power to quality measurements, and into which sectors can we? Is it any not sectors, any systems, or how applicable is it to the different sectors, whether it's commercial, industrial, or is it mainly on the utility side?
Thanks, Steph. Yes. So no, it's not just mainly on the utility side. I think it's wherever you have assets, and you have, as I said earlier, where you have this combination of a utility and assets on the grid, or connected to the grid, and you want to look at protecting both sides, as well as your revenue stream, to understand the data in a granular format. Obviously, there is a cost behind the Elspec devices, and at the moment it's more commercial, high-end commercial, industrial type utility applications. However, we do a lot of studies on the networks for various different clients. So if there is a one-off before and after that we need to do, but I think it's driven by the finance. It's driven, if you put in a 500,000 Rand system on top of the roof, there's an asset that you want to be able to manage. If you're looking at a large scale farm, there's a revenue, especially for the IPPs. You are pushing kilowatts back onto the grid. You want to be able to manage that stream. If there's a problem, you want to be able to understand it in a quick format, being able to do something about it, being able to react to it. So no, it's a cross-board. We're not quite in the domestic market yet. The Asaf might be able to answer that question if he's still there. But I know there's things on the card, so I'll leave that one up to you, Asaf, if there's any development going on there.
Yeah, basically we are our solution is the best case in the point of common coupling for relatively large solar fields. What we find out in recent years is that all the renewable energies that playing around, creating a new events on the grid and new phenomena that we didn't aware before. Now the utility have the the motivation first to cut out the renewable energy from the grid. They believe that this is the fault for everything. And as an asset owner, having the device, ELSPEC device, is the black box like in the airplane, to show to the utility that you behave exactly as expected. This is something that gives you an edge over the utility on one hand. On the second hand, we know that the utilities and the regulator are continuously changing the codes, the grid codes and the requirements from the asset owners. Having a traditional meter to take a measurement out can found irrelevant in few years, because the demand become very strict. They start to request more high resolution data. They start to request it for longer time. And we see in many places around the world how the asset owners approach to ELSPEC by themselves because the regulator changed the rules. So having this technology in advance give you kind of a safety net that you have what you need for 10, 20 years from today.
Fantastic.
Great, thank you so much. I think, yes, we're running a bit short on time, but we're going to try and squeeze in a few more questions. Michelle, you're next on my list. Thank you so much for your presentation. It was very insightful. One thing that I always find so fascinating about Ecopia is how you don't use water and you derive all your energy from the panels itself, which is something that I've always found absolutely interesting. One of the questions that I do have is, in terms of maintenance, how frequently do you need to do maintenance on your robotics?
So it depends on the site. It depends on the site of the sites, the amount of robots, but we have annual maintenance checks on the robots, components, and the microfiber. So we initiate those visits on site. We also share the visits and malfunctions and everything that we took care of in the client's data hub. So our customers are always in line with the operation that is going on site. But besides that, we can track and monitor the robot's operation through the online software. So we know in advance, for example, if a robot needs a replacement of a battery or anything like that. But in general, there is no need for human intervention except for scheduled in advance annual checks.
It's very interesting that you mentioned that you use, obviously you're tracking it remotely. Tell me, in the instance that this will be in the rural DRC or in the Namib Desert or so on, what do you need to connect it to the software or to the dashboard? Is it running on Wi-Fi? Is it running on Bluetooth? What is used to connect it?
So we have a communication program for every site that we install. We take care of all of the communications in terms of the connections between the robots and the communication center. We make sure that the communication is working even in severe weather conditions, which is something that we start to see more and more of. And if needed, we can always take care of specific functions that are happening in terms of connectivity in creative ways.
No, fantastic. Hilton, I think this is also a question that's applicable to you, because a lot of the substations are also located in rather rural areas and remote areas. So how do you ensure that there's always connectivity, especially in crucial times when downtime is not really an option?
That from the metering perspective that you speak in.
Yes.
So look, connectivity is a challenge. However, I think we overcoming that in various different forms. However, a lot of the outlying areas are, if you don't have a normal GSM, 4G, 3G type connectivity, there are satellite sort of available options that you can use. And I think it comes down to understanding the networks before you go into it, and what do you want to feed back from that particular network. But yes, there are ways to overcome those challenges, and I think Africa is a vast continent, yeah, but I think there are definitely solutions out there.
I will add another issue is that the ability of the meter to record the continuous waveform on board for a significant time. We can record for more than 1 year on board. Then the real-time connectivity is not essential to have the data. We do have a management system, a software that collects the data from anywhere. But the real-time connectivity is not essential, and the onboard recording is easy. Also, the fact that we compress the data at the 1 to 1,000 ratio make it easier for challenge connectivity's area because the bandwidth is not too high.
That's correct.
Oh, very interesting. No, thank you so much. The value of compression is always so vast. That
Yes.
I think that's something moving into the future. I'm really getting off of track, but moving into the future, I think we're going to see more compression of data as everything is going online, moving to more of a digital field. Ben, I'm gonna poke you again, if you don't mind. But
yeah.
One of the questions in the question box was, we understand that Ecopia pretty much has annual maintenance of the equipment. Tell me, we know that you have an unmanned vehicle on the ground, and obviously you're exposed to very rough areas and so on. How frequently is it necessary for maintenance on your vehicle and your cleaners as well?
Yes, thank you. So basically, one rowboat of ours takes care of up to 100 megawatt, cleans up to 10 megawatt per day, up to 20, depends on the system configuration. I must say, Steph, our system also conducts dry cleaning and saves water, so it's important to emphasize that.
It wasn't my question, so I just didn't bring it up. I apologize.
No, of course, it has to be said as well.
No.
And basically, when having one system on site compared to perhaps thousands of different several utilities on site, maintenance becomes relatively more simple. We're talking about 3 main components: a ground rover, electric vehicle that is powered by the sun as well, and we're going to have local crews that will basically on contract fix whatever kind of malfunction that occurs within a day. So even if it comes to a point where you need to replace the entire vehicle, it's super easy because we're talking about identical vehicles that requires no installation, and everything is already implemented within the computer in the cloud. So simply changing them with one another, it's a very easy fix. So therefore, we're able to really guarantee that the entire farm is overviewed physically and both digitally in any given time. Yeah, thank you
so much, Peter. I'm gonna finish with you. And my question for you is, what I really find fascinating about your technology is that you don't just focus on either the electricity generation or the thermal energy that you generate, but more the storage of the thermal energy. Because we know that for any system to work in the PV space, you need proper storage. So tell me, Peter, like the storage that you have, storing the energy in water, how long can you store the energy, and how frequently do you need to attend to it?
Okay, in principle, the concept rely on compressing air, and it's in high pressure, and the idea is to convert this high pressure air in small tanks and to generate an engine that consume, let's say, relatively to the compressing, it's about 40%, which means it's doubling the production relative to the compressing. It can work, depend what is the size, but in principle, it can work about 25 hours a day. We make a test and we have stored 3.5 megawatt and we produce 400 kilowatt output, and it's very good. And our intention is to do everything in the urban area, exactly where they need this energy, and they need this storage in the city, which mean we can have the microgrid can supply the energy that there is the demand. As I said, the electricity, hot water, the storage, and that's the perfect solution to bring the energy to the city.
Noted. No, that is very insightful. Thank you so much, Peter. I think,
Sorry, I want to mention,
yes,
there is no degradation. It's very important. It's mechanically, it's no lithium battery, and it's can stay for 50 years and more. Wow.
no, that's very impressive, definitely. So yes, I think unfortunately we ran out of time. I would like to ask all our attendees to please reach out to me if you want to meet any of the companies here or if you need more information. Secondly, I would really like to thank Power Africa for their very insightful message, and I would like to thank all our panelists today, Ben, Warren, Peter, Michelle, Hilton, Asaf. It's been such a pleasure to learn more about this field, and I really look forward to working with you going forward. Of course, a very special thank you to Nava, and a very special thank you to Yuval. This has been a great journey, and yeah, we're looking forward to the next one. Thank you guys all so much, and yeah, have a great day.
Thank you
Thank
so
you.
much, everyone.
Thank you. Cheers.
Thank you.
Bye-bye.
Thank you very much.
Thank you. See you. Bye bye.
Thank you.